Linear tape open is a magnetic tape data storage technology originally developed in the late 1990s as an open standards alternative to the proprietary magnetic tape formats that were available at the time. Hewlett-Packard, IBM and Seagate initiated the LTO Consortium, which directs development and manages licensing and certification of media and mechanism manufacturers. Seagate's tape division was spun off as Certance and is now part of Quantum Corporation. The standard form factor of LTO technology goes by the name Ultrium, the original version of which was released in 2000 and could hold 100 GB of data in a cartridge. LTO version 6 released in 2012 can hold 2.5 TB in a cartridge of the same size. Upon introduction, LTO Ultrium rapidly defined the supertape market segment and has consistently been the best-selling supertape format. LTO is widely used with small and large computer systems, especially for backup. Historical context: half-inch magnetic tape has been used for data storage for more than 50 years. In the mid-1980s, IBM and DEC put this kind of tape into a single reel, enclosed cartridge. Although the physical tape was nominally the same size, the technologies and intended markets were significantly different and there was no compatibility between them. IBM called its format 3480 and designed it to meet the demanding requirements of its mainframe products. DEC originally called theirs compact tape, but later it was renamed DLT and sold to Quantum Corporation. In the late 1980s, exabytes data 8 format, derived from Sony's dual-reel cartridge 8-ohm video format, saw some popularity, especially with Unix systems. Sony followed this success with their own now discontinued 8-ohm data format, Advanced Intelligent Tape. By the late 1990s, Quantum's DLT and Sony's AIT were the leading options for high-capacity tape storage for PC servers and Unix systems. These technologies were tightly controlled by their owners. Consequently, there was little competition between vendors and the prices were relatively high. IBM, HP and Seagate sought to counter this by introducing a more open format focusing on this market segment. Much of the technology is an extension of the work done by IBM at its Tucson lab during the previous 20 years. Initial plans called for 2 LTO formats to directly compete with these market leaders. Ultrium was half-inch tape on a single reel, optimized for high capacity, and XLs was supposed to be 8-ohm tape on dual reels, optimized for low latency. Around the time of the release of LTO-1, Seagate's magnetic tape division was spun off as Seagate Removable Storage Solutions, later renamed Certance, which was subsequently acquired by Quantum. Ultrium. LTO Ultrium was developed as a replacement for DLT and has a similar design of a 1/2-inch wide tape in a single reel cartridge. This made it easy for robotic tape library vendors to convert their DLT libraries into LTO libraries. Compatibility between generations of drives, formats, and cartridges is as follows. An Ultrium cartridge's dimensions are 102.0 A, 105.4 A, 21.5 ohm. An Ultrium drive reads data from a cartridge in its own generation and at least the 2 prior generations. An Ultrium drive writes data to a cartridge in its own generation and to a cartridge from the immediate prior generation in the prior generation format. Generations: as of December 2012, LTO-6 was the latest generation. Further generations are planned as tabulated below. LTO-1, first commercially available in September 2000. Ultrium 1 specification is now standard ECMA 319, initial capacity of 100 GB. Initial data transfer speed of 20 MB per second, tape encoding is RLL1, 7. LTO-2, first mechanisms approved in February 2003. First media approved in March 2003. Double capacity to 200 GB. Increased data transfer speed to 40 MB per second. Switch to PRML encoding. LTO-3, first media approved in November 2004. Doubled capacity to 400 GB. Increased data transfer speed to 80 MB per second. Introduced worm feature. doubled number of write elements in head. LTO-4, first mechanisms approved in April 2007. First media approved in May 2007. Double capacity again to 800 GB. Increased data transfer rate to 120 MB per second. Introduced drive-level encryption feature using 256-bit AES-GCM. LTO-5, specifications announced January 19, 2010. The first LTO-5 drives appeared on the market in Q2, 2010. Nearly doubled capacity to 1.5 terabytes, increased data transfer rate to 140 MB per second. Introduced partition feature that allows tape to be split into two separately writable areas. This feature is required by LTFS. LTO-6, licensing specifications announced June 11, 2012. Increased capacity to 2.5 TB, increased estimated data compression ratio due to a larger compression buffer. Increased cartridge memory to 16 KB. Increased data transfer rate to 160 MB per second. Notes, data capacity and speed figures above are for uncompressed data. Most manufacturers list compressed capacities on their marketing material. Capacities are often stated on tapes as double the actual value. They assume that data will be compressed with a 2-to-1 ratio. See LTO-DC below. The units for data capacity and data transfer rates generally follow the decimal SI prefix convention and not the binary prefix convention. Minimum and maximum reading and writing speeds are drive-dependent. Positioning times, while specifications vary somewhat between different drives, a typical LTO-3 drive will have a maximum rewind time of about 80 seconds and an average access time of about 50 seconds. Note that because of the serpentine writing, rewinding often takes less time than the maximum. If a tape is written to full capacity, there is no rewind time, since the last pass is a reverse pass leaving the head at the beginning of the tape. Tape durability, 15 to 30 years archival. 5,000 cartridge loads/unloads, approximately 260 full file passes. The following durability figures are quoted from Imation Corporation's expected usage life of Imation media. There is a large amount of lifespan variability in actual use. Regularly writing only 50% capacity of the tape results in half as many end-to-end tape passes for each scheduled backup, and doubles the tape lifespan. LTO uses an automatic verify after write technology to immediately check the data as it is being written, but some backup systems explicitly perform a completely separate tape reading operation to verify the tape was written correctly. This separate verify operation doubles the number of end-to-end passes for each scheduled backup, and reduces the tape life by half. Technical features, linear tape file system. The linear tape file system is a self-describing tape format and file system, which uses an XML schema architecture for ease of understanding and use. It allows files and directories to appear on desktop and directory listings, drag and drop files to from tape. File-level access to data, supports data exchange, with LTFS tape media can be used in a fashion like other removable media. With LTFS the drive may behave like a disk but it is still a tape with serial access. Files are always appended to the end of the tape. If a file is removed from the listing the associated tape blocks used are not freed up, they are simply marked as unavailable. Data is only deleted if the whole tape is reformatted. LTFS now supports library mode facilitating access to multiple tapes in a tape library. LTFS was first introduced with the IBM LTO Gen 5 drive. The Linear Tape File System Technical Work Group of SNIA works on the development of the format for LTFS. Tape layout, LTO Ultrium tape is laid out with 4 wide data bands sandwiched between 5 narrow servo bands. The tape head assembly straddles 2 adjacent servo bands, with 2 servo read heads and 8 or 16 data read-write heads. Each data head moves up and down within its own data subband the same width as the servo band. First, the head assembly is positioned so all tape heads are at the top of their subbands and 8 or 16 tracks are written in the forward direction. Then the head assembly is moved to the bottom of each subband and 8 or 16 tracks are written in the reverse direction. The set of tracks written at the same time is referred to as a wrap. Alternating forward and reverse wraps are written as each data subband is filled up in 0, 2, 4, 5, 3, 1 order. When the first data band is filled, the head assembly is moved to the second data band and a new set of wraps is written. The total number of tracks on the tape is A. For example, an LTO2 tape has 16 wraps per band, and thus requires 64 passes to fill. The block structure of the tape is logical, so interblock gaps, file marks, tape marks and so forth take only a few bytes each. In LTO1 and LTO2, this logical structure has CRC codes and compression added to create blocks of 403,884 bytes. Another chunk of 468 bytes of information is then added to create a dataset. Finally, error correction bytes are added to bring the total size of the dataset to 491,520 bytes before it is written in a specific format across the 8 heads. LTO3 and LTO4 use a similar format with 1,616,940 byte blocks. Worm, new for LTO3, was write once read many capability. This is normally only useful for legal record keeping. An LTO3 or later drive will not erase or overwrite data on a worm cartridge, but will read it. A worm cartridge is identical to a normal tape cartridge of the same generation with the following exceptions: the cartridge memory identifies it to the drive as worm, the servo tracks are slightly different to allow verification that data has not been modified, the bottom half of the cartridge shell is gray, and it may come with tamper-proof screws. Worm-capable drives immediately recognize worm cartridges and include a unique worm ID with every dataset written to the tape. There is nothing different about the tape medium in a worm cartridge. Cartridges compliance-verified licensed manufacturers of LTO technology media are EMTEC, Imation, Fujifilm, Maxell, TDK and Sony. All other brands of media are manufactured by these companies under contract. Since its bankruptcy in 2003, EMTEC no longer manufactures LTO media products. TDK withdrew from the datatape business as of the end of March 2014. Verbatim and Quantigy both licensed LTO technology, but never manufactured their own compliance-verified media. Colors. The colors of LTO Ultrium cartridge shells are mostly consistent, though not formally standardized. HP is the notable exception. Sometimes similar, rather than identical, colors are used by different manufacturers. UCC means Universal Cleaning Cartridge, which works with all drives. Different manufacturers use different names for the same color sometimes. The names in the table above come from each manufacturer's own documentation. Worm cartridges are two-tone, the top half of the shell is the normal color of that generation for that manufacturer, and the bottom half of the shell is a light gray. Cartridge memory. Every LTO cartridge has a cartridge memory chip inside it. It is made up of 256 blocks of memory, where each block is 32 bytes for a total of 8 KB. This memory can be read or written, one block at a time, via a non-contacting passive RF interface. This memory is used to identify tapes, to help drives discriminate between different generations of the technology, and to store tape use information. Every LTO drive has a cartridge memory reader in it. The non-contact interface has a range of 20 ohm. External readers are available, both built into tape libraries and PC-based. One such reader, Veritape, connects by USB to a PC and integrates with analytical software to evaluate the quality of tapes. This device is also rebranded as the Spectra MLM reader and the Maxell LTO cartridge memory analyzer. Leader pin. The tape inside an LTO cartridge is wound around a single reel. The end of the tape is attached to a perpendicular leader pin that is used by an LTO drive to reliably grasp the end of the tape and mount it in a take-up reel inside the drive. When a cartridge is not in a drive, the pin is held in place at the opening of the cartridge with a small spring. A common reason for a cartridge failing to load into a drive is the misplacement of the leader pin as a result of the cartridge having been dropped. The plastic slot where the pin is normally held is deformed by the drop and the leader pin is no longer in the position that the drive expects it to be. Older single-reel tape technologies use different means to load tape onto a take-up reel. Labels. The LTO cartridge label uses the barcode symbology of USS 39. A description and definition is available from the Automatic Identification Manufacturer's Specification Uniform Symbol Specification and the ANSI MH10.8M 1993 ANSI Barcode Specification. Erasing. The magnetic servo tracks on the tape are factory encoded. Using a bulk eraser will erase the servo tracks along with the data tracks, rendering the cartridge unusable. Mechanisms. Current compliance verified licensed manufacturers of LTO technology mechanisms are IBM, Hewlett-Packard, Quantum, and Tandberg Storage. Cleaning. Although keeping a tape drive clean is important, normal cleaning cartridges are abrasive and frequent use will shorten the drive's lifespan. LTO drives have an internal tape head cleaning brush that is activated when a cartridge is inserted. When a more thorough cleaning is required, the drive signals this on its display and/or via tape alert flags. Cleaning cartridge lifespan is usually from 15 to 50 cleanings. There are two basic methods of initiating a cleaning of a drive: robot cleaning and software cleaning. Compression. The LTO specification describes a data compression method LTO-DC, also called streaming lossless data compression. It is very similar to the algorithm ALDC, which is a variation of LZS. The primary difference between ALDC and SLDC is that SLDC does not apply the compression algorithm to uncompressible data. Every block of data written to tape has a header bit indicating whether the block is compressed or raw. For each block of data that the algorithm works on, it saves a copy of the raw data. After applying the compression function to the data, the algorithm compares the compressed data block to the raw data block in memory and writes the smaller of the two to tape. Because of the pigeonhole principle, every lossless data compression algorithm will end up increasing the size of some inputs. The extra bit used by SLDC to differentiate between raw and compressed blocks effectively places an upper bound on this data expansion. LTO-DC achieves an approximately 2:1 compression ratio when applied to the Calgary corpus. This is inferior to slower algorithms such as GZIP, but similar to LZOP and the high-speed algorithms built into other tape drives. It should be noted that plain text, raw images, and database files typically compress much better than other types of data stored on computer systems. In contrast, encrypted data and pre-compressed data would normally increase in size if data compression was applied. In some cases this data expansion could be as much as 15%. With the SLDC algorithm, this significant expansion is avoided. Encryption. The LTO-4 specification added a feature to allow LTO-4 drives to encrypt data before it is written to tape. All LTO-4 drives must be aware of encrypted tapes, but are not required to actually support the encryption process. All current LTO manufacturers support encryption natively enabled in the tape drives using application-managed encryption. The algorithm used by LTO-4 is AES-GCM, which is an authenticated, symmetric block cipher. The same key is used to encrypt and decrypt data, and the algorithm can detect tampering with the data. Tape drives, tape libraries, and backup software can request and exchange encryption keys using either proprietary protocols, or an open standard like Oasis's Key Management Interoperability Protocol. Error detection and correction. The tape drives use a strong error correction algorithm that makes data recovery possible when lost data is within one track. Also, when data is written to the tape, it is verified by reading it back using the read heads that are positioned just behind the write heads. This allows the drive to write a second copy of any data that fails the verify without the help of the host system. Prices. As hard disk drive prices have dropped, disk has become cheaper relative to tape drives and cartridges. As of 2013, the cost of an LTO-5 drive taking tapes of up to 1.5 TB true capacity was about $1,800. As of 2013, a tape cartridge is still cheaper than a disk drive, as a 1.5 TB magnetic tape cartridge costs about $40, whereas a hard disk drive with the same capacity costs about $70 to $100. Sales figures: the presence of 5 certified media manufacturers and 4 certified mechanism manufacturers has produced a competitive market. This has led to attractive prices for customers and high sales volumes for manufacturers. In 2002, LTO outshipped SDLT by nearly 2 to 1. Sales since then have dominated other super formats. As a result, Quantum discontinued development of new DLT products in February 2007, and Sony followed suit by declaring AIT end of life in March 2010. Unsuccessful LTO variants: some planned LTO variations were not produced, or produced only briefly. Excelis: LTO technology was originally designed to come in 2 form factors, Ultrium and Excelis. As of 2008, LTO Ultrium was very popular and there were no commercially available LTO Excelis drives or media. In common usage, LTO generally refers only to the Ultrium form factor. Excelis was developed in 1997 for fast access to data by using a 2-reel cartridge that loads at the midpoint of the 8-ohm wide tape to minimize access time. IBM's 3570 McStar MP product pioneered this concept. The real-world performance never exceeded that of the Ultrium tape format, so there was never a demand for Excelis and no drives or media were commercially produced. Multiple lengths of LTO-1 tapes: the first generation of Ultrium tapes were going to be available with 4 types of cartridge, holding 10 GB, 30 GB, 50 GB, and 100 GB. Only the full-length 100 GB tapes were produced. HP LTO-1 cleaning strategy: HP LTO Gen 1 drives have a cleaning strategy that will prevent the drive from actually using the cleaning tape if it is not needed. In a change of strategy, HP LTO Gen 2, 3 and 4 drives will always clean when a universal cleaning cartridge is inserted, whether the drive requires cleaning or not. See also: magnetic tape, tape drive, tape library, data compression. References. External links: IBM's LTO Redbook, a IBM Systems Storage Tape Library Guide for Open Systems, Linear Tape Open, a Consortium homepage, ECMA 319, a specification of Ultrium 1, IBM LTO Ultrium cartridge label specification, revision 3, a free generator for LTO labels, a free generator for colored LTO labels.